All right, welcome back for lunch. We now have a talk from Cody. Cody, another former Objective ISC speaker. So let's give Cody a warm round of applause.
Thank you. All right, so quick poll for the room. How many people have heard of Kerberos? Okay. How many people would say you're familiar with Kerberos? Okay, nice. All right. How many people have their Macs hooked up to some form of Active Directory environment? Nice. Okay. Well, this will be maybe pretty informative, maybe not. This covers a lot of research I've been doing into Kerberos as it is in macOS for Active Directory environments and for the local KDC. So if you don't have an Active Directory environment, how are you still leveraging Kerberos? So I am Cody Thomas. I am an operator and instructor at SpecterOps, so I do a lot of red teaming engagements. I also help teach our red team operations course. I'm also an open source developer. I have AppFell out there, which is a red team open source C2 framework that you can use. Bifrost is a project that we'll be using in this talk today. There's also Orchard, which is another project that goes through and leverages Open Directory to try and access some Active Directory attributes. And then there's a link to my GitHub for all these projects that are already out there now. So a quick overview about what we're going to be covering. So brief intro to Kerberos, all the different steps to it. I do have a lot of material to cover, so we will be going a little fast. So I tried to color code things to make it a bit easier to follow as we go through each of these things. Then we'll go through a step-by-step walkthrough if you're doing Active Directory attacks from a macOS for the second part. And then the last part will be the LKDC, how you actually interface with Kerberos on a Mac that isn't connected to Active Directory at all. So, a quick Kerberos introduction. What is it? So it's an authentication mechanism invented by MIT in the 1980s. Of course, back then, everything was use as few bytes as possible and use as much crypto as possible. So it's super annoying, super frustrating to delve into. It's based on this client-server model that's stateless. So you, the client, are trying to do something with a server that kind of has this perfect knowledge of the world. And everything in it is scoped to this realm. So this will pop up a couple of times throughout the talk, but a realm is just kind of what the key distribution center, what this Kerberos instance is the authoritative server on. There are many implementations of this. Of course, the traditional, most true to form one is MIT's implementation. They're the one who did create it. But of course, this can be augmented with a bunch of plugins that are out there now. This is usually what you'll see if you're on some sort of Linux distribution. Windows has its own modifications that they've added, and of course, macOS does whatever they want to, and they do their own things as well. So now we start talking about Kerberos specifically, all these different steps. I try and break this down, not get too specific. So in the beginning, the client and the key distribution center have some sort of shared secret. This is how all this cryptography is going to be going on. You have some shared secret that's already set up with the KDC. Okay? Then the client makes a request to the authentication server that has the KDC on it, and you're doing this authentication server request to try and get some sort of ticket. Okay? So you do that request. You get back from your AS request, your authentication server request, and authentication server reply, right? This request reply, you'll see this back and forth a bunch. So this reply comes back with a ticket to the KRB TGT service principal name. Lots of letters, lots of words, I know. Trying to make these a little bit easier. You can think of KRB TGT. I highlighted the TGT part. So think if you see that, you're going to be getting back a TGT. A TGT is a ticket granting ticket. It's a ticket that allows you to get more tickets, okay? Sounds pretty confusing, but the words kind of describe what's happening here. So this process is the AS rep. This TGT, you can think of it as your own new identity. Before you were using usernames and passwords, that's how you knew you were who you are. In the Kerberos realm, this TGT is the thing that identifies you as who you are, okay? It's already been proven with this. Part of this TGT is encrypted with the KRB TGT's hash, okay? This is how, through all the cryptography, they're able to verify that this is who you say you are because I can prove where it came from based off of this hash. Okay, now you have a TGT. You have a new identity. We can prove that you are who you say you are. Now, you're still trying to do something in this environment. So you go through and you present your TGT to the ticket granting service, TGS, and ask to speak to another service. So this is going back to the authentication server, back to this area. You're saying, all right, I am proving I am who I say I am, and I want to, I don't know, mount this drive on this other computer. So it's looking up that service, you're requesting access to that service. That is a TGS request. From that, you get a TGS reply. You'll see this back and forth all again, TGS request, TGS reply. You get back a service ticket to that service, all right? Now you actually want to leverage that. So you supply that ticket to that service, and it checks if you have the right authorization to do that thing. Lots of things, I know, lots of stuff going on. We'll go through all this step by step. This is just kind of the high level overview as things are happening over and over again. So all the way up to the point where you are providing that ticket to the final service is doing an authentication check. Just, are you who you say you are? It's only at that very last step are you doing a check to see if you're actually authorized to do whatever it is. So you can get tickets as any user to maybe mount the admin dollar share on the DC. Sure, get it, you can have the ticket, but it's only whenever you actually try and use it that'll check, oh, you're not authorized to actually mount admin dollar, right? It's only at that very last step. So a couple other little like Kerberos 101 extras that kind of fall into this. So I mentioned this before, the KDC is bound to a realm. This is what the KDC knows about. In Active Directory, this is your FQDN, your fully qualified domain name for your domain, okay? Tickets have expiration times. They can be renewed, they can be revoked, they can have all these different kinds of properties associated with them. And all these services have a backing service principal name. That's how we look up what we want to do. So say you want to mount the admin dollar share of this DC. Well, in Kerberos, you have to look up what that even means. You're requesting access to a specific service on the DC, namely to access its file share. And so it has to be able to look up all that information. It does all this with the fully qualified domain names of everything that's going on. The reason it doesn't use something like an IP address to access that, because your IP addresses can change. Theoretically, your host name should stay the same as you go out and you do things in Active Directory. So that's why it uses this to look it up. So if you have maybe a domain controller in your environment that you're trying to access, and you try and do this a Kerberos process with an IP address, it won't work because the IP address isn't what's actually stored in Kerberos. Okay, lots of stuff. We're going to be doing heavy Kerberos stuff today, so should cover why do you care? Why am I even talking about this? So as a red teamer, usernames and passwords can only get you so far. And especially as we're talking about macOS stuff, sometimes that's kind of hard to get. Depending on how you get your initial access onto the computer, you may or may not be able to get the user's password, and there may be more protection stopping you from getting it. So that might not even be an option. Kerberos tickets are just as valuable as a username and password. Remember, your TGT is your new username and password. So I can use that to be you just like I would your username and password. Oftentimes we see, especially on macOS environments, these TGTs and Kerberos properties are way less protected than your username and password. Think about how many times you hear about somebody's TGT or Kerberos stuff on Mac. Nobody's talking about that. They're always talking about, oh no, your plaintext password. That's the thing. But these are just as valuable. And because there are more moving pieces in this, if you do have one of these pieces compromised, it's harder to go through and make sure everything is set back to a secure state. With a username and password, you can just, all right, reset its password, we're good to go, right? As a blue teamer, there's more authentication logs that you need to look into. There's more credential material that you need to track throughout the environment, especially as you do maybe forensics or look to see some incident response on a box. What is a potential, what kinds of passwords and credential material could they have taken from here to move throughout the environment? I did a poll last October just to see how many times people are actually experiencing Active Directory and Kerberos in macOS-based red teams. It's about what I expected. 70% of people see Active Directory bound Macs maybe 0 to 25% of the time. So not too much, but there is a 30% group that is seeing this at least 25% of the time. So it's kind of worth digging into to see what all we can uncover from this. So now we'll start doing a deep dive into how this process happens on a Mac and how you can see some of these attacks kind of formulate throughout the process. So I keep saying this word Heimdal. What is it? So if you're familiar with Norse mythology, which I don't know why you would be, but if you are, Heimdal is the one who guards the Bifrost, which is the Rainbow Road in Asgard. This is where Thor, Loki, Odin, all those people live. Apple, for some reason, whenever they forked Kerberos and made their own implementation, they called it Heimdal because Apple. So they also dropped one L because Apple. So that's what you'll see here. We'll see Heimdal all over the place. If you're curious, this picture is from Marvel. This is their implementation, their version of Heimdal on the Bifrost. So this is why the tool I wrote to go do all this Active Directory manipulation, Bifrost, because it's related to Heimdal. It's not completely random, I promise. So in macOS, how do you start going about using all this sort of stuff? So there's a handy Kerberos framework that you can just link to your project and start accessing all these APIs. Also, throughout these slides, I'm doing a whole bunch of API calls and doing stuff in Objective-C for a very specific reason. So especially from a red team perspective, I like to have access to everything that's going on the system and make sure that what I do now is kind of future resilient, at least a little bit. Apple went through and made a post as they were talking about Catalina that at some point going forward, at some time TBD, third-party scripting languages might be removed from your boxes by default. So you might not have Perl, Python, Ruby, all this sort of stuff. So there are other implementations of this sort of work, at least in the Active Directory realm, in things like Python. But if that's going to be removed by default, and I happen to be doing a red team engagement where I happen to land on, I don't know, an HR person's Mac, they're not going to install Python with brew, cask, or any of that sort of stuff. So I have to leverage something that's actually going to be there. So I'm going through and doing all this sort of stuff with API calls. And as we go through and we start talking about all the different Kerberos traffic, I'm doing all this manually. This is very similar to a project that Harmjoy Will Schroeder did called Rubius, going through and directly connecting to Kerberos on port 88 and doing all this traffic manually. Throughout all these slides, the kind of user context and stuff we'll be dealing with, there's a test domain with a test lab admin user, and the computer that we'll be doing this from is the spooky.test.lab.local computer, okay? So if you're curious about how to do this in Xcode, it's pretty simple. There's a build phase that you can go to, where you can just link libraries, and you can just link, there's a Kerberos.framework. Pretty easy to get up and get started. So that's stage one. I said in the beginning, there was a shared secret. What is that? So in Active Directory and in Windows, you're not sending your clear text password around. You're not even sending in some cases, you're not sending your hash of your password around either. Active Directory doesn't know your plain text password. It knows hashes of your password. So you have to go from plain text password to one of these hashes. That's the shared secret that you're going to be using for this. Active Directory knows many versions of this hash, such as RC4, AES 128, 256-3, all these different ones. And it has these for backwards compatibility reasons based off of the OS version that you're trying to talk to and what kind of domain you're in and all this sort of stuff. So if we want to go through and take our plain text password and get this hash, Heimdal has us covered with this KRB5 C-string to key function that allows us to take a C-string representation of our password and get back a key. So the main ones we'll be concerned with here is RC4, which is an unsalted hash. So in your normal Windows environment, you can think of this as your NTLM hash. There's also the AES 128 and 256, which are salted hashes. So what is this salt? Luckily for us, this salt is a known thing in these environments. If you're talking about a normal user account, the salt is the fully qualified domain name in caps with the username appended to it. If you're talking about a computer account, so this is like your computer dollar account, the salt is just a little bit different because reasons. So in that case, it's the fully qualified domain name, all uppercase, host, the computer name that you're trying to do, and the fully qualified domain name, again, all lowercase. Because why not? But at least it's known. As we go through and we do this from a red team perspective, RC4 hashes are super nice because they're not unique across domains. Remember, the RC4 here isn't unsalted. So there's no domain-specific material getting added into this hash. That's super nice. RC4 is also a bit easier to crack than AS128 and 256. Now, I mentioned this computer account thing a couple of times. If you're curious about that on your own Mac, you can view the plain text password of this account. You just go to your system keychain. There is an Active Directory / and then the NetBIOS name of your domain that you're connected to. So in test.lab.local, that's the fully qualified domain name. The NetBIOS short name for that is just test. So you can see up here, there's an application password in the keychain under Active Directory test, where I can just see the plain text password. Fantastic. I like that. You can also see this if you're using DSCL on the command line. So we need to go from plain text password to hash. We can do this with Bifrost, where we can just ask hash provide the information that we need, like the domain, the username, and the password, and we can get our hashes here. So you can see here's the example of the test lab admin user with the salt of just the domain and the username, we get our hashes. If you're talking about the computer account, spooky dollar, you can see here our salt is a bit different where it has that host in there and the fully qualified domain name again, okay? Something to note here as well, as you'll see, this RC4 hash starts with 3411. You'll see where we can verify that we're correct here in a couple slides. So that's awesome, lots of stuff that you can do, but what if your users hate typing in their passwords? Because I know everybody loves typing in their passwords a million times a day, right? Yes. So if you don't like that, then there's a thing that you can use called a key tab. So I know you're super intuitive, you guessed it, a key tab is a table of keys. Pretty easy, goes through by default, all of you have one in etc krb5.keytab. It is locked down to root access only, and this has information about your computer dollar account. So users can create their own though. If they don't want to type in their password every time they're doing this to access Kerberos-based resources, they can create their own key tab, which can potentially be less locked down than to just their user. So this is another thing that's nice to kind of search for on computers as we're doing red team engagements to find these saved credentials. So you can use Bifrost to go through and parse these key tab files. They're pretty straightforward. And so you can see here that we're going through opening up the key tab. We can see principals, so like this is trying to access the VNC. This is the computer dollar account that I was mentioning before. And here you can see that 3411. So this is the RC4 hash of our computer dollar account that's already saved in the key tab. So we don't have to go through the whole process of trying to generate that ourselves. If we're already elevated on the box, we can just pull this file and have all these hashes already. So you can also see here, I'll talk about this in a little bit later, but if you notice, this is the VNC service on this spooky computer, and this is the spooky dollar account, okay? Both of these have the exact same hash. Spooky. I'll talk about that in a little bit why that's the case. So different attacks already at this point that can happen. So if you can compromise the user's plain text password, then you can generate their shared secret. We just went through the process of how you generate these, and now you can do all this traffic yourself. If you compromise the user's hash, so the computer dollar or the user's hash that we're using in this environment, then you can use that to do this traffic manually yourself. Because remember, we're trying to take that plain text password and get these hashes anyway. So if you just get these hashes, you're already one step down the road. In Windows, this is usually over past the hash or past the hash, depending on if you're trying to inject this material into LSAS or not. For us, though, it doesn't really matter that much because we can just do this manually on the wire. If you're able to get the RC4 version of this hash instead of like the AES 128 or 256, it's a bit easier to crack. And this allows you to essentially be that user account. Once you have that hash, you can do everything as them. Okay, now we're actually going to start doing traffic on the wire for Kerberos. So this is stage 2, the Authentication Server request. We're trying to get that TGT. So we're trying to go through and prove that we are who we say we are, so we can get this new Kerberos-based ID. If you look here on the left, Kerberos traffic is in this weird ASN1 dir encoding format, which of course back then was super awesome because it limited the amount of bytes we had to send, but it's super annoying to parse. So this is just a kind of broken out representation of what that data is. So we can go through, and there's something to note here. As you're going through and you're doing these requests, you say who you are, you prove who you are, and you say what you want, okay? So for this request, we say who we are, we say what we want. So we want access, we want that KRB TGT, we want a TGT, but how are we gonna prove that we are who we say we are? We just have this hash. Well, in Windows Active Directory, we have this thing called the PA data enc timestamp, which, you guessed it, means we will encrypt a timestamp. Awesome, right? So we'll use our hash to encrypt a timestamp to prove that we are who we say we are. So that's what we start doing here. Remember, say who we are, prove that we are who we are, say what service we want. You'll see this process over and over again. So that's why you'll see for these TGT requests, we're requesting specifically the KRB TGT for this realm. If you look here, remember the thing we're encrypting to prove that we are who we say we are, it's just a timestamp. It really is just a timestamp. So we just get a time of now, we add a couple of bytes in front of it for this ASN1 encoding, and we go through, and Heimdal has this KRB5C encrypt length function that allows us to just take that data, take in a key, encrypt it. Pretty awesome, pretty straightforward, allows us to authenticate as ourselves. So what kind of attacks can happen here in stage 2? So one thing to note is that this sort of stuff, this encrypted timestamp, is a Windows thing. In traditional MIT Kerberos, it doesn't have this requirement. The idea being that, well, if you request a TGT as that user, it doesn't matter if you don't prove that you're that user, because part of the data will be encrypted with that user's hash. So if you don't have that hash, if you're not that user, you can't decrypt it. All good, go home, boys. 1980s, we're good. The problem with that, though, is now you have a hash of data, you have encrypted data for that user that you can crack. So that's why we go through and we do this pre-auth request, doing that encrypted timestamp, so you're not able to just get weak hashes for all the users in the domain and crack their passwords. This is the general idea behind AS rep roasting. And it's called that because you're doing information based off of the AS reply, the one for the TGT. So as we do this, what is happening in stage 3? So the authentication server and the KDC want to validate what we sent them in our request for the TGT. Okay, so they're doing a couple checks. Does this user exist? Is it an active account? Is this KDC that you're trying to talk to authoritative over the realm in which you're talking? If it's not, then you start doing these inter-realm trusts and all this sort of stuff, which I won't get into because that gets even more complicated. But more stuff happens there. You're checking to see if the user does exist and is active. Does the hash that the KDC have for that user match what it is you're trying to do? And can it decrypt it? All of this also checking to make sure that this timestamp is within the past couple of minutes. They're trying to make sure that you're not going through and doing replay attacks for captured traffic a long time ago to get another TGT. Okay, if you answered yes to all of this, you get a TGT. If you said no to any of it, you get an error. So say we go through, we do that, we get this reply. This is the AS rep. This is the reply with our TGT. Because Kerberos is a stateless protocol, it sends back a lot of data every time because you're not able to track what's happening between each request. That's why you see all of here. This is just a rehash of all the data we sent in our request. This part here, 5, is our actual TGT. This is the part that we care about. But this part down here at the bottom, 6, is a part that's encrypted with our user's hash. So this is a little bit of extra information. So up here, the TGT has, most of it is encrypted with the KRB TGT's hash. So we can't look into it. This is something that we will pass on with further requests, that the KDC can decrypt and validate that it was the KDC that sent this initial TGT. If we look into that encrypted part, though, that we can decrypt, element 6, we see, the most importantly, here is another key that we can use. This is the session key that we'll be using for the next set of requests. Lots of different keys going around, lots of different encryption stuff going on, but we have to keep track of this key as well for as we do further requests. You can also see how long the ticket will last. You can see the different flags that are set on the ticket. So is it renewable? Is it forwardable? All this sort of stuff, all that's contained in there. So now that you have this TGT, awesome. What happens to it? On a Mac, where does it go? Where is this saved? What's going on? So on macOS, these tickets are stored in a format called Ccache. They're credential cache. By default on your Mac, they're managed by a KCM. So this is a process-based daemon that's living on your computer that will handle all these requests transparently for you as you hit these APIs to pull out this data. So each cache is assigned a random UUID. There's one principal per cache, which is you, and you can have multiple tickets within it. Okay, all those tickets should belong to that same one principal. You can have multiple caches on a system. One will be your default, but you can specify any of them to use. So you can have multiple different TGTs that you then swap between as you go through and do additional requests. Additionally, so that's kind of protected. That's the default. Apple likes to do that sort of stuff, protected by default, it's saved in memory. If you want to, though, you can specify to have this drop to disk. This is the default on a lot of Linux boxes. Instead of saving an API in memory, they save to disk. And so by default, that's in etc, and it'll be like krb5 underscore and a UUID. So you can just cat those if you're elevated on the box and kind of get everybody's TGT, which is pretty dangerous. So if we start listing out these credential caches, what does that even look like? So here we're listing with Bifrost, and you can see a couple of things put out here. So we have this principal. This is us, test lab admin. That's our principal. And within it, we have a bunch of tickets. So each of these has an API and a UUID. This is the name of the cache. These are the principals for the service, for the tickets that we've requested. So if the service principal is KRB TGT, that's our TGT, our saved TGT. And then other ones you'll see are for the service tickets that are stored in there. And of course, you can see the different flags that are associated with this as well. So now what if we want to take the ticket from one computer and use it on another? This is pretty common in red teaming. You're on one box, you're elevated, you take those tickets. Maybe now another box is dual homed, has connections into other environments that you want to leverage, you want to move it over there. So don't worry, Kerberos does not know where it sent that ticket to, and it doesn't track it, it's stateless. So we can use this Kirby format to go through and save all the data from that element 5 and 6, save it off, and move it between boxes. So we can go through here, we dump the tickets that are in our credential cache. You can see, this is the client, the test lab admin, the principal, this is his TGT, because you have here the KRB TGT. You can see the encryption type, the key, all this sort of stuff. And down here, this big blob is the actual ticket and encryption material that we'd need to move between boxes to be able to do that. So if we're going to be passing tickets, how do you import them on the next box? Well, you can inject tickets into any credential cache that you have, whether it's in memory, on file, wherever. There's just a couple of things that have to happen. You have to take that Kirby format and convert it back into a credential cache format. And you have to resolve the name and get the actual address that you're trying to put this credential cache information into. And you have to just append it to the list. Remember, this is just a big dump of tickets within these credential caches. So if we're going to start doing this, we can do it in a couple of steps here in Bifrost. We can list out the tickets that we have. All we have is a TGT. So we want to inject a ticket into this credential cache. So we look at the name here. All right, now we're going to inject. So here's action PTT, pass the ticket. We're going to inject it into this API, and all that basic before stuff above it is the ticket we're actually going to inject. And so you can see down here, we go through those couple of steps. Parse the Kirby data, create it into a credential cache format, resolve the name, and you can see here, this is the credential. So this is this CIFS service for this domain controller, and we'll inject that in. So you can see down here, now after we list, it's already been injected. So it's pretty simple to go through and pull out tickets and inject them back in. There's no real protections going on between them, nothing really stopping you from pulling them out, manipulating them, doing all this sort of stuff. So what kind of attacks can happen here? That was kind of a big section with all that AS rep. So the idea here is if you can capture that KRB TGT hash that is signing part of that data in element 5 for your TGT, if you can get that hash, then you can forge your own TGTs. This is called a golden ticket attack because you can just mint your own golden tickets to be whoever you want in the environment. If you can dump those tickets from the KCM, then you can use them wherever and you can impersonate that user and act as that user in that environment. And then of course, if you're able to do the AS rep roasting, maybe on traditional MIT Kerberos, then you can go through and start cracking their passwords as well. So now we go through, stage 4 is we want to actually do something with that TGT. So it's a very, very similar process. We want to talk to the TGS to get a service ticket to something. So again, who we are, prove we are who we are, and say what we want. So in this case, we are saying who we are. Our proof, instead of an encrypted timestamp, is our TGT that proves that we are who we say we are. And then we go through and we use that to request a service ticket to the thing that we're trying to access. So any user with a valid TGT can request a service ticket to any service in the environment. There's no authorization checks happening, right? Just authentication. Services must have the backing SPNs. So the example here is we're looking out for the CIFS. Spooky.test.lab.local is an SPN that we can use. And we can specify any encryption scheme that we want. So we can say we have the AES-256 hash and that we want the ticket to come back in RC4. So we can do all these granular requests if we're doing this manually on the wire. So the TGS and the KDC will validate what we sent them in this request. Can the KRB TGT hash decrypt the TGT that we sent them? Did that KDC actually send that TGT? Right, that's the first check that's going on. Was it done within the past 20 minutes? If it's kind of like a performance boost check. If it's already been granted within the past 20 minutes, it assumes that everything in there is still valid. You haven't updated Active Directory in any way, so it just trusts everything that's in there. Does the SPN that you're requesting actually exist? Can it find it? Does it have a shared secret? All this sort of stuff, checks that are happening. If you got yes to all the above, you get a service ticket. Congratulations. When that comes back, it looks pretty much exactly like what we had when the TGT came back. Element 5 has our service ticket. Element 6 has information encrypted with the hash that we're using. So this is the service ticket, this is information, and again, notice, even if we use the AES-256 hash, we can get the result back being RC4, okay? So that second piece down there at the bottom, element 6, again, this one, our hash, the AES-256, is what we'll use to decrypt it and see another session key that we can use for further requests. So now that you have a service ticket, where does that go? Does that have any sort of differences for our service ticket versus a ticket granting ticket? The answer is no. So they both go into the same spot, and you can dump them just the same. So again, here is dumping this service ticket. Again, a Kirby blob that you can take and inject anywhere else. So what kind of attacks can happen here? Well, if you know the shared secret of the service account, then you can make service tickets to that service. So you can be anybody but to that service. This is a silver ticket attack. And if you use a valid TGT, you can request service tickets for any service at any encryption level. So you can say, hey, I want a ticket to that service. I want it to be RC4, so I can then crack it. So that is the idea behind Kerberos, being able to request a lower encryption. So this is an example of dumping that out into a hashcat format of an RC4 encrypted ticket. Okay, that was all Windows Active Directory. Lots of stuff going on, I know. But now what if you're not in Windows Active Directory? What happens? Do you care about any of this sort of stuff so far? Good news, maybe, is you do still care, because you might still be using it. So starting in OS X 10.5, Apple introduced Back to My Mac. So they've since discontinued this, but all the underlying technology and stuff is still here and still being used. So the goal was to allow users, without any centralized management, just two people that happen to be near each other, be able to access each other's resources. So be able to mount their shares, be able to VNC, be able to do this sort of stuff without needing some sort of big centralized management server in the middle. So you can see this here. If you look into your sharing settings, there are only a couple of these that apply for this. This is screen sharing, file sharing, and remote management. Those are the three big ones. Okay. Starting in 10.14, Mojave, Back to My Mac is no longer included, but like I said, everything is still there under the hood, still operating. So when you want to connect remotely to a Mac with a local account, what's actually happening? Everything we've covered so far has been with Windows Active Directory. There's been a domain, there's been all this centralized management. Well, now you're sitting here with just two Macs. What is going on? So you're still going to be using Heimdal to authenticate, get tickets, and access resources. This is still going to be happening on port 88, but there's no Active Directory, no domain. So what do you do? Well, Apple has you covered with this local key distribution center. So when your computer first boots, very first time, it creates a self-signed certificate, com Apple Kerberos KDC, okay? This certificate is stored in your system keychain. All of you can view this now on your own computer and see the certificate. The realm for your Heimdal instance that's happening on your specific computer is based off of the SHA-1 hash of this certificate. So if your certificate starts with B58C, then the realm for your computer will be LKDC SHA-1 dot and then your hash. Okay, everybody's will be unique and different. You can also go through, if you look at your launch daemons, system library launch daemons, there's a com.apple.kerberos.kdc daemon that you can look at. There's an associated plist that'll show you the different services that your computer is sharing out whenever this sort of Kerberos traffic is turned on for your computer. So you can see here, there's the Apple file server, there's SMB, there's screen sharing, okay? If you're curious about this, if this is running on your box or not, you can do one of two things. You can check and see if you have port 88 on your computer open and listening. You can also check launch CTL and see if this daemon is running, if it has associated paid with it. If it does, then congratulations, you're using Heimdal, you're sharing the service via tickets. You're welcome. So if you want to take a further step into this, I mentioned a couple services that are there running on your computer that leverage this. If you look in your Etsy KRB5 key tab, you all have this, you can see a bunch of different services that are here. These are the services that your computer is sharing out and the associated keys with them. So this is the backing key, for example, the APFS server for your CIFS for mounting file shares. This is the shared secret that the computer has with the key distribution center. So if you have these hashes, then you can then make your own silver tickets to the computer. So remember, this was talking about before in Active Directory, you get the backing accounts hash, you can make your own silver ticket, be anybody to that service. That's what's happening here. If you take these hashes, you can make your own service tickets, be anybody to that specific service. Okay? Now, if you want to go one step further, because you have all this local on your computer, you also have your own KRB TGT, which you can look at here with DSCL, or you can use Orchard to go through and pull this. There is a Kerberos keys attribute that's there on this account. You can see it here pulled out in base 64. But if you run the user libexec configure local KDC, this is idempotent, so you can run it as many times as you want. If the certificate exists, nothing will happen. If that certificate I was talking about before doesn't exist, the one with the SHA-1 hash that you're using based off your realm, if that doesn't exist, this binary is the one that will create a new one and update all your hashes. So you can go through, see here, pull out this base 64, and if you base 64 decode that, you actually get more ASN1 encoding, because who doesn't love ASN1? It breaks out into this, and if you actually look at the details that are here, you can see integer 18 means AES256 salted hash. Here's the hash you'd need. Here's one for AES128 and DES3 CBC SHA-1. So these are the different hashes for your KRB TGT account. This allows you, if you take these hashes, to mint your own TGTs to your computer. So you can be anybody to any service on your computer. So now let's say we want to actually access your computer. We want to do all this Kerberos traffic to your local KDC. How does that work? Because remember, all you know is your password, and that remote computer has some sort of realm, which is unique and a SHA-1 thing you're not going to guess. So how do you figure all that stuff out? So you're going to make an AS rec. Remember, the initial one we did was an AS request. This time, though, since you don't know what realm, you're going to make it to this well-known com.apple.lkdc realm. This is a special thing that Apple has that allows you to say, this is a generic request. Give me information. So Kerberos will respond with a generic error that's saying it's redirecting you to the correct LKDC. So you do this request, you get back a response that gives you the correct SHA-1 and realm that you're trying to talk to on the remote computer. Anybody can access that. If you notice, we did no authentication for this. So you can query this for any computer that's out there in the environment. So as part of this, you still don't know the shared secret that you're going to use. Right? All you have is a password. The LKDC uses this special protocol, the secure remote protocol, that allows you to go through and do this kind of like a Diffie-Hellman key exchange aspect to be able to get a new shared secret and key that you're going to use for the rest of the protocol. If you remember though, Kerberos is stateless, so it doesn't actually know what state you're in as you're trying to go through and do this back and forth for this key exchange. So of course they added in this PAFX cookie thing that you now have to get in your requests and kind of relay back every time you do these requests. You get a new one each time you do a request. Super annoying, but this is in the same area as we were doing that encrypted timestamp before. Okay, so now that you know the realm, we still need to know what shared secret we're going to use. In Windows, we were using just the RC4 or AES256 hash. It's not the case here. If you've ever done anything with Mac, you know that your passwords aren't saved in plain text, and they're not saved in just a hash. Instead, they're saved through this PBKDF2 function with assault and like 80,000 rounds and all this sort of stuff, right? So it's a bit different than just doing a normal hash of your password. If you're ever curious and look at your own shadow hash data, you can do this with DSCL here, or you can use Orchard and get a base 64 version like I have here. You can see a couple of interesting things. So you can see up here, your salted SHA-512 PBKDF2, this is your normal Apple password. It's gone through like 80,000 rounds, SHA-512, all this sort of stuff. But there's also this other thing down here. This SRP RFC 5054 4096 SHA-512 PBKDF2. Mouthful, gross, but it's the thing that we're looking for as we start doing this SRP protocol to talk to the local KDC on your box. So this big blob down here is the verifier. This is the server-side shared secret. In Windows, both sides had the shared hash, and that's how you did things. In this case, though, they're a bit different on either side. So if you're curious, it's a bunch of math and hashes and stuff that's going on to be able to generate this thing. But we go through, now that we know the remote realm, the LKDC SHA-1, whatever SHA of the remote box, we can do another request. But we still haven't proven that we are who we say we are. We've just started a request to that realm. So what we get back, though, is some information to start this SRP process. So we get back the cookies that we're talking about, so we can keep state, and we get back this information about the salt we're going to be using, how many rounds of PBK DF2 we're going to be using, all this sort of stuff. So this starts to get pretty complicated, lots of stuff going on, lots of back and forth messages. You're using big ints, big numbers to do like Diffie-Hellman key exchange style. I won't go into all that. But you do a couple more requests and you get a TGT, okay? So that TGT you can treat just like any other TGT that you would have normally. So if we look at our credential cache that we dump after doing this process to talk to a local KDC, we get two things that we would expect normally. So we get our TGT and a service ticket. Awesome, looks good so far. But what are all these other random things that just got added in here? We have these char b5 c cache conf data random things at x conf esh. Like what is going on here? What is this stuff that wasn't in there before? So if we look at it though, and look at all these individual pieces, it kind of gets a little scary. So we can see down here, there's an LKDC hostname, which is the remote computer name that we were talking to. Okay, that's fine. We can see the associated friendly name, i.e. the username that we authenticated with. Okay. But there's a typed password. This is the plain text password that we just used to authenticate to that remote box. Going through all that stuff to do a secure remote protocol, doing hashing, key exchange, PBK DF2, all this sort of stuff. Whoops, doesn't matter, let's just store the plain text password. So that's there if you want it. So there are a couple of different attacks that you can go through with this. If you know the user's password, then you can go through all this process yourself, just like we did normally, just like we kind of did with Windows. If you get the char b TGT hash, then you can generate your own TGTs as any user to any service on this box. This is again the golden ticket to that box. If you get any of the hashes from the etc char b5.keytab file, those hashes are the ones for all the services on that box. So if you have those, you can mint your own service tickets, i.e. silver tickets, to any service on that box. So in this case, golden tickets and silver tickets are essentially the same because everything is all living and encapsulated on that one box. So again, you can be anybody to any service on that box. And if you're able to steal the user's SRP verifier, that big blob I showed in the shadow hash data, you can also use that to crack the user's password. Additionally, if you go for the user and read their Kerberos keys, you can get this either with DSCL or Orchard to pull out this attribute. You can see here, there is also the stored user's hashes that we're talking about from Active Directory. So again, you have the user's AES256, 128, and in this case, instead of an RC4, there's the DES3 CBC hash that's going on here. And so all this information, again, you can see the salts are based specifically for this LKDC. It's not for any Active Directory route. So again, you can use all these to try and crack their passwords as well. So it's a lot of stuff. Summary for all this. If you are on a Mac, you're using Heimdal. Sorry, it's happening. All this sort of stuff comes into play. But you have to start considering how often do you change your user account password. Okay, maybe if something happened, maybe you get paranoid, you change it. Do you ever look and change your char b TGT password? Do you ever change your computer's password? These things, most people don't even know exist. So you may be compromised, change your user account password, think, hallelujah, I'm safe, but now I can just mint golden tickets and silver tickets back to your box and access them that way. According to Apple, the LKDC should not come into play if you are joined to Active Directory. That's true, but only for Active Directory accounts. If you start using the local accounts, then the LKDC does come back into play and all this sort of stuff falls in. One good thing to note is that these tickets in your credential cache are flushed periodically. If you're mounting a drive with LKDC and all that sort of stuff, the moment that you disconnect, these tickets should be flushed, including the plaintext password. So you'd have to be able to dump this while it's still being connected, which if you have long-running connections, you're kind of out of luck. But if you happen to connect and disconnect pretty frequently, then maybe the attacker doesn't catch that plaintext password in memory. So that was a lot. I know there's links up to Bifrost that's up there. I will update the code today for all this LKDC stuff. I still haven't added in the things to generate the golden and silver tickets. That's coming soon. And then I have a post up there along the same lines that has demo videos to go through, taking a user's password, getting the hash, injecting into memory, mounting remote shares, all that sort of stuff, doing this as well. So that's the end of my stuff. Thank you. I know that was a lot, I'm sorry.
I have question from someone on the line.
Okay.
They said, I just finished a game with a bunch of Macs joined to Active Directory. I was able to capture hashes from them using Responder. I wasn't able to get a lot of detail from the customer. That's all they said so far. Quite fast would work. All right, maybe I'll
Okay.
Oh, here we go. On Windows, the remediation strategy is straightforward. Turn off, modify the registry, etc. How do you remediate this on OS X?
Ooh, for Responder. That's tough because lots of the stuff that's going on is just replaying stuff and broadcasting stuff that's happening in the network. Depending on what's going on, you can try and turn off like Bonjour and MDNS that's going through and broadcasting all the stuff like advertising your services. But I'm not sure for like a easy stop fix to stop that stuff from happening.
If you turn off those services, would that have other impacts? Or?
Yeah, so like if you're trying to do things where you, especially for like AirDrop, it's using that to then broadcast these other computers, and you can even see there's a binary that you can run on there that'll list out all the different services that your computer's broadcasting. So you can even see other computers that are connected to the same network that are broadcasting like SSH and SMB and all that sort of stuff.
So basically, as a red teamer, you're stoked.
Yeah.
Awesome. Let's give Cody one more round.